Today we're going to be looking at direct and inverse variation. First, when we look at direct variation, the general equation is y equals kx when k does not equal 0. So k cannot be equal to 0. We use this equation y equals kx. K is called the constant of variation. So if we're given a problem and it says if y varies directly as x, so here we know we have direct variation because it told me that it varies directly, and y equals 24 and x equals 3, we want to find the constant of variation, and then we want to find y when x equals 2. So as soon as it tells me it varies directly, we want to start by writing our direct variation equation. So we're going to start by writing y equals kx. We know we're dealing with direct variation, so we're going to start with our equation y equals kx. It tells me that y is 24 and x is 3. Because I now know an x and a y, I'll be able to solve for k to find that constant of variation. So we're just going to plug it in. Y is 24. We're not sure what k is at this point, and x is equal to 3. So right now we have 24 equals k times 3. To get k by itself, we need to divide by 3. So we'll get k, our constant of proportionality, to be 8. So if we rewrite our direct variation equation, now that we know what that constant is, my new equation is y equals 8x. We're going to be able to use this equation to find any other x and y values that it might give me. So here's my constant of variation was k. K equals 8. We use that to write our new direct variation equation, and now we can answer part B. It says to find y when x is 2. Well, we need to know what y is. We know that my k value is 8, and it tells me that my x value is now 2, so we're going to plug in 2. When we solve, we get y is equal to 16. Okay, so my direct variation equation, I started off with y equals kx. I plugged in the x and y value that it gave me so I could solve for k. I used that k value to rewrite my direct variation equation, y equals 8x, because 8 is my new k value. And using that, we are able to find y when x is equal to 2. Let's try another one. Here it says y varies directly as x. Again, as soon as it says that, we want to write down y equals kx because we're dealing with direct variation. It says directly. And x equals 8 when y equals 9. So we're going to plug in exactly what we have. X equals 8, so we don't know what k is. X is 8 when y is equal to 9. We solve for k, divide by 8. So we get k to equal 9/8. We're going to rewrite our equation. So we get y equals 9/8x. Now it says to find y when x is 12. So again, it gives me the x value. I want to find the y value. So we're going to plug it in. We've got 9/8 times 12. Okay, if we want to reduce this down, think about what's going on here to solve a simpler problem. If you don't have a calculator nearby, you can think of 12 as 12/1. Here things reduce. 8 and 12 can both simplify because they have common factors. They both divide by 2. They also both divide by 4. So if I divide them both by 4, I end up with a 3 on top and a 2 on bottom, which makes this much easier to multiply these two fractions. So when I do that, now I'm going to multiply what's left on top. So we've got 9 times 3 on top, which is 27, and 2 times 1 on bottom, which is 2. So my y would be 27/2. Okay, so the things that I'm looking for when you give this to me is I'm looking for your work to get the k value, I'm looking for the new equation, and the answer to the question that it finally asks. Please make sure that you show me the equation, the direct variation equation, with your k value plugged in. Okay, so now we're going to look at a word problem. This says, according to Hooke's law, the force F required to stretch a spring x units beyond its natural length varies directly. So here we have our y equals kx. As soon as you see that, write it down. A force of 30 pounds stretches a certain spring 5 inches. Find how far the spring stretches by a 50-pound weight. Okay, so here it's talking about force to stretch a spring x units. Okay, so it doesn't give me an x and a y value. Here it gives me force and our x units. So we've got the x units, but our y value is really is really an f in this situation. So I'm going to rewrite this as f equals kx. So that way as we plug in, it's a little bit easier to find what we're looking for. So here it tells me a force of 30 pounds stretches it 5 inches. So here's my two values that work together. So we're going to use those two values to plug in and find our k. So a force, that's my F of 30 pounds. So we're going to plug in 30 for F. we're looking for k, stretches the spring 5 inches. 5 inches, that's my x units, so we're going to plug in 5 for x. Divide by 5, and we get our k value to be 6. Again, we always want to rewrite our equation, so my force is equal to 6 times x units. The question then asks me to find how far the string is stretched by a 50-pound weight. So it gives me the force, okay, it gives me 50 pounds of force because we want to find how far, so we're looking for that length. So here it gives me the F value. So we're going to plug 50 in for F equals 6 times X. We want to solve to see how far the string has been stretched, so we will divide by 6. Okay, so that leaves me with 50 divided by 6. You can reduce that fraction. You know that 50 and 6 both divide by 2. You can think about if they both divide by anything else. They don't, so they both divide by 2, so we get 25 over 3, which in this situation we're dealing with inches. We wouldn't normally talk about 25 over 3 inches, so if we think about what that is, 3 goes into 25 8 times, and we'll be left with a third, 1/3 left over. So this would be 8 1/3 inches is how far it will be stretched. Okay, so make sure your answer makes sense in the problem. You wouldn't tell somebody it's 25 1/3 inches or 25 over 3 inches. You would say 8 1/3 inches. So make sure it makes sense. Make sure you have your units on there. Okay, now we have inverse variation. I know this screen has kind of gotten messed up. It says y varies inversely as x if y equals k over x, such that k does not equal 0, such that xy equals k. This is really the equation we're going to be dealing with. So direct variation was y equals kx. Inverse variation is y equals k over x. Okay, because as y goes, they're going to vary inversely. They're going to go in opposite directions. Okay, so when it says inverse variation, you need to remember the equation y equals k over x. So here it says find y when x equals 15 if y varies inversely as x and x equals 10 when y equals 12. Okay, so it says it varies inversely, so we'll start with y equals k over x. So it starts off on this one, it says find y when x is 15. Here's my question that it's asking, the final question I want to give me, but we're looking for that x and y pair so we can find our k value. It gives me the x and y pair over here to the right. Over here it says x is 10 when y is 12. So we know those two values go together. When x is 10, y is 12. So we're going to be using those to plug in. So my x is 10, k is on top, 10 is on bottom for my x, and y is 12 in this situation. We need to solve for k. So since this is k divided by 10, we're going to multiply both sides by 10. We'll end up with k, because those will divide to 1, equals 10 times 12, which is 120. So my k value is now 120. Just like before, now we're going to rewrite our equation. Y equals 120 divided by x. Now we can go and address this problem that it asked me. It said to find y when x is 15. So we're looking for y when x is 15. So we'll have 120 divided by 15, which when we do that, we get 8. So when x is 15, my y value is 8. Again, I'm looking for your equation with your constant plugged in, and I'm looking for the answer that it asked for. Okay, let's do another one. Now it says to find x when y equals 27 if y varies inversely. So we start with y equals k over x. And x equals 9 when y equals 45. So there's my pair. So my y value is 45. We have k over my x value is 9. To get k by itself, we multiply both sides by 9. So we have 45 times 9, which is 405, equals k. Use that to write your equation again. So we have y equals 405 over x. The question here says find x when y is 27. So now my x value is missing. My y value is 27 equals 405 over x. Now we're going to have to take a couple steps to solve this problem. Because we have an x on the bottom, we need to get that x off of the bottom. We want to move it to the top. The only way to do that is to multiply both sides by x. So we're going to multiply both sides by x. That's going to give me 27x equals 405, because here the times x divided by x will divide to 1. We still need to get x by itself, so now we're going to divide by 27. And that will leave me with 405 divided by 27, which is 15. Okay, so in order to do this problem, we plugged in what it gave us to find our constant of variation. We plugged that back into our equation. We had y equals 405 over x. We plugged in the y value it gave us to solve for x. Because x was on bottom, we had to multiply both sides by x, and then divide by that 27 that was out in front to get x ultimately by itself. So again, I'm looking for the equation, and I'm looking for your final answer. Okay, now we're going to look at an application problem. It says the pressure P of a compressed gas is inversely proportional. So here's our inversely related, so y equals k over x, to its volume V according to Boyle's law. A pressure of 40 pounds per square inch is created by 600 cubic inches of a certain gas. Find the pressure when the gas is compressed to 200 cubic units. Okay, so we know we're dealing with inverse variation, but we need to plug in what it gives us. It says the pressure is inversely related to the volume. So we're going to say our pressure is inversely related to the volume. We're just going to write it down in order. It's going to read in the appropriate manner. So P equals K over V. So we want to plug this in. It says a pressure of 40 pounds is created by 600 cubic inches. Okay, so my pressure is, my P is 40. My volume is 600, so we're going to plug that in. We've got 40 equals K over 600. We solve for K. We get K to equal 600 times 40, which would be 24,000. So there's my K value. We want to rewrite our equation. P equals 24,000 over my volume. It says find the pressure when the gas is compressed to 200 cubic inches. So now my volume, because cubic inches is a unit of volume, is 200. So we're looking for the pressure, is 24,000 divided by 200. Okay, remembering how to do easy division, those zeros will cancel out. So now we've got 240 divided by 2, which is 120. This is pressure. We need to make sure we put units in, so if we come back up here, it's always giving me my pressure in pounds. So this would be 120 pounds of pressure.